Of the variables we talked about, which one most affects the force of drag or the air resistance force? So let's talk about the things that do affect it. Someone tell me one thing that affects air resistance, the drag force. Jorge, give me one thing. What affects air resistance?
Air density.
Okay, we got one. 10. So air density is one. Say again? Yes, the area or the cross-sectional area, however you want to say that. I'm also okay if you say size, because that's essentially what cross-sectional area is. Okay, we got air density, we got cross-sectional area. What else? Say again? Velocity, yes. And one more. Nope, but that is a really good guess, and I'm glad you brought up mass because I want to talk about it. Yeah, the aerodynamics of the object. It's called the coefficient of drag. Okay, coefficient of drag. Another way you can say it is shape. I'm also okay if you say the shape of the object. All right, so those are the four things that affect it. Air density, cross-sectional area, velocity, aerodynamics. I also mentioned you could say size for this one. Okay, of those four, pick one that you think matters the most. Think about which one is most likely to change. Shape will usually stay the same, not always. But generally, when we're talking about dropping objects, we're talking about more solid objects. So, like dropping a rock or dropping a ball or a human being going. So, like, they'll generally keep their shape most of the time. So, not the area, but that's a good guess. Or not the shape, that's a good guess. Velocity, this is the one. Velocity is most likely to change because as you fall, gravity accelerates you, which means you will go faster and faster and faster. And so as you go, you're going to increase your air resistance. Whereas you're generally not going to increase air resistance due to the other objects because the other objects are going to be constant, or the other variables. Mass. Let's talk about mass. Mass does not affect the force of drag. It does indirectly, but not directly. So, what does mass affect? It affects something else. Caden, what do you think? What does mass affect? Yes, video game. Starts with a T. Ends with velocity. It's a name for something at an airport. You were going to say terminal velocity, right? Good. I knew you would. Terminal velocity. Okay. Mass does not affect what the force of drag is. It affects how large the force of drag can be, but it doesn't affect the actual value. So the mass of an object does not affect how fast it's falling at any moment. It only affects how fast it can go at the maximum. That's all mass affects. Okay? So make sure you're careful on that, which I believe that is a question on there. One of the questions is something about mass or terminal velocity. I thought there was one about what affects terminal velocity. Yeah, why does it happen? Yeah, we might as well look at that one. So, since we're already talking about terminal velocity, so terminal velocity is the maximum velocity an object can reach. Generally, we think about it for free fall, but it doesn't have to be. It doesn't have to be free fall. It could be like a car driving. Like a car has a limit as to how fast it can go, and part of that is air resistance and acting on the car. So maximum velocity it can reach, and explain the reasons. Why does this happen? It's because Fd increases as you fall. Right, we talked about that up here with drag force. So drag force increases as you fall. Eventually, Fd equals Fg. Again, here's my object, here's drag force, here's gravity. Eventually, those will equal each other, and then the net force is 0. If the net force is 0, nothing changes. So eventually it gets to the point where the net force is 0 and it stops speeding up. Yeah.
So theoretically, let's say you drop something like on Earth in a vacuum, would it just keep speeding up so there's no drag?
Yeah. It would never stop speeding up. It would go to essentially infinite speed. Yeah. Which you could test that if you wanted to do it on the moon. Now the difference on the moon is acceleration is much less, so it won't go near as far. And its gravity effect is less, so like you wouldn't be able to lift it as high for it to fall. But yeah, like if you could create a vacuum on Earth, such as if some group of spacefaring evil people came and sucked all the air out with a vacuum, yes, everything would fall indefinitely. They would never stop. Little Spaceballs reference for you all. Any other questions on 9 or 10? Bingo, bango.